Hey guys, hope you are good. So today I'm gonna teach you Kirchoff's current law, and I know once you understand the concept you will easily solve the numerical. So Kirchoff's current law. So the basic definition of this law is in a linear bilateral network the algebraic sum of all the currents at any node is equal to 0. What does it mean? It means summation I is equal to 0, or elaborate this formula I can write I of incoming minus I of outgoing equal to 0, or I can also say in a linear bilateral network at any node the total incoming current is equal to total outgoing current, that is summation of total incoming current is equal to summation of total outgoing current, and this law is also called nodal analysis. Now from diagram I can write like this is a node and current I1 is entering into this node and current I2 is entering this node, and current I3 is leaving this node and current I4 is leaving this node. So according to this law, I1 plus I2 is equal to I3 plus I4, or I can write I1 plus I2 minus of I3 plus I4 equal to 0. Now to clear this law we should solve one numerical, and that's why this is the numerical that we are going to solve in today's class. So gentlemen, as we also done in our last questions, first of all let me clear you this question. This is 1 ohm resistance, 1 ohm resistance, 2 ohm resistance, 2 1 2 and 1 ohm resistance is 10 volt. This is a 5 volt source, this is a 4 volt source, this is ground voltage which is equal to 0. This is node A, this is node B. So current is moving in this direction, and at this junction we have a voltage VA, and current divides into current I1 and current I2. So this is I1 current, this is I2 current, and this I2 current further divides into current I4 and current I3, and we have voltage VB at this point node. Now we have to solve this question step by step, so watch the class till end. Okay, so step 1, applying KCL at node A. So this is the incoming current, so I is equal to outgoing current, that is I1 and I2. So I1 plus I2. Now using the formula I equal to V upon R, let's open this I, so we will get 10 minus VA upon resistance, which is 1 plus 1 2 ohm. So we got 10 minus VA upon 2, and this is the potential difference which we are writing here. Okay, and I1 is VA minus VB upon 1. We are subtracting the next voltage from the initial voltage because we have a potential drop at this resistance, and that's why definitely VA is greater than VB, and similarly at this point tan is greater than VA because there is some potential drop, and that's why we have write 10 minus VA, and at this point we have write VA minus VB. Okay, now I1 plus VA minus 0 upon 2. Now solving this equation we will get 10 minus VA equal to VA plus 2 VA minus 2 VB. So we will get 4 VA minus 2 VB equal to 10. And this is our equation number 1. Now applying KCL at node B, and this is our step 2. Okay, so here we have I2 which is entering the V2B node, is equal to I3 plus I4, and we already find that I2 is VA minus VB upon 1 is equal to I3, which is equal to 2 VB minus 5 upon 2, and we have subtracted 5 because we have taken the direction of the current in downward direction, but according to source 5 volt the current is going in upward direction. That's why we have taken negative sign. Now I4 is equal to VB minus 4 upon 1 and 2 3 upon 3. Again same thing is happening here. The R current is going in downward direction, but 4 volt source is sending current in upward direction, and that's why we have put negative sign here. Now solving this equation, we will get 6 VA on taking LCM. 6 VA minus 6 VB is equal to 3 VB minus 15 plus 2 VB minus 8. So on solving we will get 6 VA minus 11 VB is equal to minus 23, and this is our equation number 2. Now on solving equation number 1 and 2, we will get VA is equal to 4.88 volt and VB is equal to 4.75 volt. So gentlemen, I tried to solve this question very easily so that you can understand each and every point. So this is all about this topic, gentlemen. Hope you understand this concept. Please subscribe to my channel, like the video and share among your friends. If you have any suggestion and want any separate topic to be discussed here, do comment below. In our next video we will learn Kirchoff's voltage law. Thank you.